I'm Hakim. I'll introduce myself, but very quickly I just want to talk about this slide. So I work at a company called Essent. It's an energy company in Belgium. And this slide represents something of what I really like working at my company. It's called the data science hierarchy of needs. So basically, these are all the things you need to do data science effectively. Companies really like starting here. AI and deep learning. And I've seen in my experience that that's really not good. They want to, I understand where they're coming from because they want to try to get as much value as fast as possible and they don't want to spend a lot of money. But the problem is that you really need data engineering first, which is what I do. I'm a data engineer. Because you really have to have a good data platform that you can then, on top of it, do the machine learning. Or else, you're going to have really unhappy data scientists. I don't know if you know this, but data science has like one of the worst churn rates for employees like of any tech field. Like they quit really a lot, and I can imagine a lot of times it's because a company hires a data scientist and then they just go do some magic and make some results. And it happened to me before, and that's why I switched jobs. So I can really understand why people leave. So basically what this says is that you need to collect your data, you need to be able to store it, you need to do very simple transformations first and explore it a little bit, and then you have to aggregate it, and then after you have all of this happening, you can then do machine learning, and then you can do AI, and you can do the more interesting things. And I just really wanted to start with that because that was super important. So then the rest of the presentation will be, I'll talk a little bit about myself, introduction to Essent and what we do. Actually, I switched this. I was not sure if I wanted to introduce the tools we use first or the workflow. It was really, I didn't know, is it better for you guys to have an overview and then deep dive into how we do it? Or is it better to have a deep dive in how we do it and then the overview? But yeah, I ended up switching it, so I'll talk about the tools first, then the workflow, and then I just have a link to a tutorial. So, about me. I like sailing. That's the first thing. I'm actually studied biology and bioinformatics, not anything to do with machine learning, although bioinformatics has a lot of overlap with machine learning. I love traveling, and I'm actually from the United States. I'm from New Jersey, and I've lived in Belgium for about 4 years now. I did the master's at KU in bioinformatics. And so a little bit about Essent. We're a retail energy company. So what does that mean is that we only deliver the energy in Belgium. We don't produce energy. We are owned by a bigger company, a German company who does produce energy, but in Belgium, we only deliver it to your door. And we don't, like, the infrastructure in Belgium is owned by the government, so it's really just an energy delivering company. And we focus on green energy and gas. Those are really our two focuses. And so the tools that we build our data platform with are all open source. We work with Spark and Scala as our main tools for building it, and on the infrastructure side, we have Jenkins, Airflow, NiFi, AWS, and for sandboxing, we have Zeppelin. I will go in detail into all of these tools and what we use each of them for and why, and maybe explain a little bit about each. And also, I'm trying to cater to everyone, but if you have any questions, just please stop me, because yeah, I'm not sure about everyone's level here. So, AWS. Basically, it's a cloud computing platform. Well, it's a lot more than that, but we use it as a cloud computing platform. We use it for data storage. We use it for web service management. We use it for API management, and it's also, the reason we use it is it's like pay as you need. So our Spark cluster, what we run Spark on, is not always on. We spin it up and down as we need it, so we don't really need to have any on-premise. So this really, it works well for us. And yeah, we use S3 for storage. And Zeppelin. So Zeppelin is our sandboxing environment. What I mean by that is this is where we have it running in a web service on AWS, and we can access our data, and we can just run little scripts to look in our data, check our data, see what's working. And what's really nice about it is that it uses like tons of languages, and you can actually mix languages. So here, yeah, it's not very clear unfortunately, but they're doing, you're doing a query and like some small transformations in Spark and Scala. And then you can actually load the table as a view, and then you can use pure SQL on it. So it allows you to mix a lot of things together, which is really, really nice. So we use that in the beginning when we just want to take a look at a new database or something. And so this is Jenkins. This is basically for our continuous integration. It manages all of our code. It allows us to like, so basically the process goes, I have something, I need to write a new function, right? And I can make a branch off of our master code. I can write the function, and then I can ask for a pull request from my colleagues, and then they have to read my code, and then they approve it. And once that's approved and in the master branch, this manages all of the release to make sure that our code is on the cluster and everything is working properly.
Is this something similar to Git?
No, that's a good question. Well, we use Git, but this is actually like, it's managing the versions of the code. So you can, like when you build a project, it will make sure that it's actually on your cluster. So Git is just for the versioning and the version controls, and like I said, my colleagues have to read my code and do a pull request. So like you make a branch, you write your code, you make a pull request, that's all Git. But then when you're actually building the code, then you do it with Jenkins.
Does it cooperate with Git?
Yes, yes. And this is also running on AWS. It's a web service. Yeah, so it's really useful that we use AWS like end to end. So our data is in AWS, our cluster's on AWS, this is on AWS. And this also lets us manage our environments. So we have, for our data, we have like our dev, our UAT, and our production environments. So sometimes you have, well, all the time, when you're testing your code, you only test it on dev, and then when it works, you go a little bit further into UAT, and then when you're really sure it works, then it will go live into production. So this also helps manage releasing the codes on every different environment and stuff like that. Airflow. So Airflow is a workflow management platform. It allows you to schedule your jobs, and also when you deploy code, it also goes to Airflow, so it will schedule your job and run the right code. And it does a lot of things, but it was also, so it was developed by Airbnb, and they happened to be so nice to open source it to us, and that's what they're currently using. And they released it in 2005. This is basically what it looks like. So this is a view of like every day. So you have here every day, and the data comes in. That's something I should mention, that most of our data processing happens in batches. So it's not streaming data. The data comes in every morning at like 9, and then that triggers the code to run. I'll explain a little bit more about that. And Airflow manages, like helps schedule that. So basically it checks every 5 minutes if there's something called a success file. And if the success file is there, it will then run the code. And it does a few more complex things than that. And then we use something called NiFi. NiFi basically allows you to ingest and egest your data. Airflow will end up triggering NiFi. I will show a diagram in the end of how everything is connected, so it will be a little bit more clear. And basically, this is just a tool that you will ingest your data. You can actually route your data based on certain attributes. So you can hook this up to anything. It can be hooked up to an API, it can be hooked up to a database, it can be like hooked up to anything you want. And it can check attributes about your files, and then it can route them to certain areas, depending on what's in your file, depending on what's in the file name. You can insert text, you can replace text. You can, in an example here, they actually convert timestamps in the data set, and you also replace the text, and then at the end you write it. So like the workflow will be that the data comes in the morning, this is triggered, it will do all of these steps, and then it will write it somewhere else. And then when it writes the data, there's the success file, and then Airflow knows to start next step in the process. So it's like super useful. And it's also like distributed, and scalable. So you can, if you're running it on Amazon, you can just say use as much resources as you need, and it will just automatically use as much resources as it needs. So that's really, really useful.
So all these old services that you are using is like some provider of the service?
And well, so the tools themselves are all open source, but you have to host them. And we host them on AWS.
Okay,
so these are not managed. We manage them.
You manage them, yeah.
Yeah, we manage them. In our pipeline, the only thing that's managed is the EMR, which is the cluster that actually runs Spark.
Okay.
And by manage, yeah, we still manage it by spinning it up and down as we need it, but we don't decide how many nodes we need. We have a budget, and it all is automatically being decided.
Okay.
So this, yes, we manage this ourselves, we host it ourselves. And it's like really powerful because you can also like do regex. You can do anything. You can like, something I use very often is like split. And what you can do, you can split all your data on one line. You can send it to an API. And then when the files come back from the API, you can merge them again. So there's like a lot of little things you can do with it. It's really a great tool.
So is it scriptable or is it only like a UI?
It is scriptable.
Okay.
So there's...
but is it, you use it or is mostly...
so the way it works, actually, that's a very good question. So the way it works is usually when we're testing it, we'll just go into the web interface. And these are called processors. And we'll set up the processors to do what we want. And then once we know it's working, that's like the test. And then we turn that into code.
Okay.
And then that code is what's launched every day and what's we do try to practice like infrastructure as code. So we try that all of our infrastructure is written in Python and that it's all automated.
And all of these steps so far are Python or?
No, well, the infrastructure itself is Python. So that's something else I should mention. Yeah, I'm in my job as a data engineer, I focus mostly on writing the Spark applications. I do not set up these tools. There is a data engineer who specializes more in infrastructure that does do a lot of this configuration, but I'm more using the tools.
Okay.
But yeah, I hope to learn how to like set them up and manage and stuff. But yeah, so technically yes, this is all Python. These are all, you can configure everything in Python with these. Anything else? No. So then a little bit about Spark. So basically in Spark you have like five different tools. You have Spark SQL, which allows you to use Spark in a very SQL-like way. You have Spark Streaming, which allows you to process streaming data. You have a machine learning library. You have a graph library, which is for graph data. And then you have some external packages. And basically this is just, Spark can handle like any data source, like CSVs, S3, anything MySQL. I'll explain like how our pipeline works towards the end. This is just a little example of a word count in Spark. So basically you just read a file and you can take the file and you do something called flat map, and basically for each line you split that line on spaces, and then you map each word to word and one, and then you reduce by key. And this is a special Scala thing that when you put underscore plus underscore, it knows that it's taking each side of a tuple. You don't have to name your parameters. It knows that it's, so basically what it will end up doing is for each key, it will count how many ones, it will add the ones, and then you will have a word count.
Okay, and I guess a flat map will return a flattened array, because otherwise you have arrays of arrays.
Yeah.
That's why you can use map by the way. Okay.
Yeah.
Does this run in distributed environment? I mean, it's a single line, but does it run on the...
Yes. If you run this on a EMR cluster, it will be distributed. If you run it locally, it will be local. That's the beauty of Spark, that it's kind of, it takes a lot of that thinking away from you, that it's really, you just have to focus on programming, and if you ran this on your local computer, it's just going to use your cores, and if you run it on the cluster, it will use as many as you need it to use. And then a little bit about Java versus Scala, word count again, but word count in pure Scala without Spark. To write a word count in Java, it will have to look like this and be really long and painful. And in Scala, it will be super short. And it's the same concept a little bit, that you take arguments, you split them on a space. In this case, you group by, and then in the map, you take each side of the tuple, and that's also a Scala thing that when you map a tuple, this dot underscore 1 is the first part of the tuple, and the dot underscore 2 is the second part of the tuple. And a little bit about Scala as well. So it's functional. It's fully functional and fully object-oriented. There's a little bit of a debate around, is it fully functional? I think it's fully functional. Some people say not because it handles input and output. And if you know anything about that, there's some die-hard functional people that say your code can't have any side effects and you can't have any inputs and outputs and then you can't interact with the outside world. And I don't really know the point of that. It can run concurrent or distributed, and it runs on the JVM, so it has like full Java interoperability. So you can use most Java libraries that you like. Actually, in Scala, you can use all Java libraries that you like. If you're going to mix it with Spark, you have to be a little careful. Sometimes they don't work.
But is Java and Scala like compatible?
Yeah,
Supposed to be compatible?
yeah. So
Okay.
Scala runs on the JVM.
Okay. But
So all Scala code is compiled into Java bytecode.
Okay.
Yeah.
And Scala is written in Java.
Yes.
Okay. Yeah. But it doesn't like its syntax
It's not like
doesn't
the change.
aim to be compatible with Java.
No.
It's like-
And Scala really, it actually stands for scalable language. It was made kind of for big data, and it has a few special things. So because it's functional, it really focuses not use for loops, not use looping in general, and that variables are immutable.
Yeah.
So that's really, it causes you to shift your mindset a little bit when you're programming in Scala. It's not like you're just gonna have a count. It's not like in Python or something where you say count equals 0 for I and then just add to the counter or whatever. You can't do that. Well, you can do it in Scala, but it would be very bad. It will let you do it, but you don't want to do it. That's not the point.
But
It
there
has,
are arrays or like immutable as well.
yes.
Okay.
Basically everything is immutable, even data frames that use in Spark.
Okay.
So whenever you do something, it can be a little bit memory intensive, so you will always save it as a new value.
Okay.
But yeah, the other thing is that all arrays and lists, they have so many methods built in that you will, I think in the past year I've written like one for loop. You almost never have to write a for loop because arrays, they have like the map, reduce, for each, fold left, fold right. There's like so many built-in methods
Yeah.
that like you can do whatever you want. And it really, once you get into the mindset, it really helps you program in a functional way. But yeah, I mean, I have quite strict teammates, so if I send a pull request with a for loop, I get yelled at. So I always have to think of how is this going to be as most functional as possible and to be as efficient as possible. Okay, so this is our standard workflow, and I want to talk a little bit. How do we get to a use case? Like, how do we decide to start one of these? Right? Basically, we have a data scientist in our team, and she works in R, and she will meet with business and discuss possible things that we want to do, and then in R, she will run through the use case on a small sample of data very quickly, just to try and get something out, see what features will be useful. See what models could possibly be nice, things like that. And then once she gets a good idea, we meet with her and then we decide how to scale it up to make it run on all of our X terabytes of data. And so back to all the tools that I talked about before is that, so you have an external data source and it will, like I said, we usually work with batch data, not streaming data. So every morning the data will come in, and that will trigger, well, Airflow is the schedule, so it's checking every few minutes if the data is there. And once the data is there, NiFi will pick it up, and it will run like what I showed you before, those boxes, like replacing text or doing whatever it needs to do. A small example is that you can actually use it to get data from other data sources. So we have an external data, like a list of account numbers, and that account numbers gets read by NiFi, and then it splits the account numbers by line, so every account number is its own file. Then it inserts the account number into a API call, then it sends it to the API, and then it gets back the actual data from the API, and then it writes it. So you can really use it to do like super complex stuff like that, and it's really, really nice for managing it. And then what happens is external data comes in, NiFi picks it up, then it goes into our raw data. Airflow is also checking our raw data. When is the raw data done being processed? Well, written to our data, it will have a success file. And then it will get picked up again, not by NiFi, but it will spin up the EMR cluster, and then it will run the cleaning code. This data will be picked up into the EMR cluster, cleaned, written again. All right? And once the data is cleaned, this is when we start getting into machine learning and interesting stuff. So we have a bunch of code that's defining our features that we need. And it will then, once the data is cleaned, Airflow will trigger the EMR again, picking up this data, creating the feature data, and writing that. And then once the features data is there, same process again, then it will do the machine learning and then write the output of the model. Then the output of the model will be sent to our business users. And that's basically the workflow. And what is this external data? So we have like a BI team at Essent, and this BI team, they really do a lot of even ETL before it even gets to us, who are analytics guys. And they have it in a Postgres database. But actually, when we're working with big data, it's not very nice to have it in a Postgres database. So we actually just flatten it. We flatten their data into a CSV, and we dump it onto S3, and it looks very much like Dropbox. And like you organize it by year, month, day. And then that allows you to filter a little bit faster, because then you're just like looking at the metadata, and then you can go to the data for each day instead of, if you want to filter something, go through the entire however many terabytes are in the Postgres database. And so I can give you an example use case is something like workforce prediction. So we have a call center, and we would like to keep our calls below, the wait time on our calls below like 3 minutes. So we need to predict how many employees we need working every half hour to make sure that our calls are below a certain amount. So then we will build a model. We will predict how many calls. Well, first we predict how many calls we will have. And then there's something called an Erlang C formula, which is not a predictive model, just a mathematical formula where you can plug in some variables. And based on the number of calls you'll have, it will tell you how many employees you need to keep the wait time below 3 minutes. And that's an example of some use case we have. And but basically every use case follows this workflow. External data, NiFi, and then it just gets pushed through this flow until we write it to an API, and then business can use it in their applications.
And are these like, so once you build them, they just stay there, and are mostly things that you like new business cases that are recurrent, or is it mostly like one time?
Well, workforce prediction is.
Yeah, that one, for example, is example of recurring
It's
one.
almost all is recurrent. So actually, this code runs every day. So it's new data is coming in every day, and then for that day, this whole process runs. And like I was saying, the thing about some companies who are really rich and are running a lot of things will keep cluster running all the time.
Mm-hmm.
For us, that's the nice thing about Airflow. It's managing all these processes, so it will only spin up the cluster when there's data there to be processed, and then when it's done, it will shut it down. Yeah. So that's basically how we work at Essent.
And the last 3 steps there, let's say from raw data to cleaned, or from cleaned to featured data, is that Spark?
Yes. Oh yeah. I should mention. All of this is Spark.
Yeah.
All of this is Spark and Scala. So our machine learning, we use Spark machine learning.
You use the ML library there.
Yes, we use the ML library. We use the ML library there. And for the rest is just Spark. And yeah, we just, there's a lot of things you have to do to clean the data and, typical data science stuff. But this is all making sure that it runs on X terabytes of data every day consistently. It's a little bit of a different mentality than the data science, but it's like super important because once the cleaned, and sometimes there's certain data types that it would just be too hard for our data scientist to clean herself. It will just take her too long. So like we have an XML data source. So actually it works a little bit reverse, that I get until this point, the clean data, and then the data scientist picks it up from here when it's written in a normal data format, not XML, and then she plays around with it, and then we decide what features we need to move forward. But most of the time, they already play around with raw data if it's possible. And yeah, we store all of our data. The raw data is usually in CSV, and the clean data is usually in something called ORC format. I think it's a binary format. But it's easy for Spark to read, and it's nice. And it's nice because ORC has the schema built in. So the schema of the data and whether a column is nullable, the nullable state of a column is stored in the file format itself.
Right.
So that's quite useful. And yeah, that's about it. Just a tutorial that I think is useful. You would have to install Zeppelin, and then there's a 5 minutes in Spark tutorial. And if you guys have any questions, feel free to ask.
I don't have a question. Okay.
Yeah, I don't know. It was quite. It was hard to gauge how deep I should go, or how
It's
I
perfect.
tried to talk about our architecture at a higher level, but also a little bit about the tools we use.
Okay. Anyway, thank you.
See how you connect the different dots, and indeed there's a logic behind. So I think I get the point of the dynamics between the different teams, which is for me the most basal way of understanding it. On the other hand, I would be interested to have some really dummy course. I don't know whether it exists online or whether you could advise something like to start playing with the concepts. There were some questions on the concepts, which for me are more Chinese.
Yeah.
But I'm not Chinese, but I understand some basic things, but I don't understand it fully.
Yeah.
What would you advise for a starter to learn first online or do kind of? I did a big data postgraduate at KUL, but
Okay.
it was still quite basic.
Yeah. So are you talking about more of like Spark and Scala, or more about how it all works together, like all of the tools, like NiFi or Jenkins?
Yeah,
or,
these kind of concepts indeed.
yeah, I think the best part is they have really good documentation, and the best thing would go to each tool and to install it and go through their documentation, and they usually have some small tutorials. NiFi is probably the easiest to play with. Yeah, Jenkins and Airflow, if you're not actually running like a data platform to test it out, is quite hard. But NiFi is like, you can just generate the file in the tool itself, and then you can do whatever you want with that file, or you can upload a CSV to it, and then you can practice with all the different, things, and then run through it.
Okay, thank you.
Yeah, problem.
Any other questions?
So I've got more experience on the analysis side than on the engineering side,
Okay.
and by doing analysis we talk a lot about data wrangling, for example, and that's a huge part of the job, and in engineering it's ETL, so I'd like to know like, exactly when does ETL end and when does data wrangling start, or is it the same thing? Or is
That's a good
Can
question.
I explain what are both? Can I explain what's data wrangling?
okay, my bad.
I didn't get that word before, sorry.
Data wrangling.
Yeah.
Yeah, it's like, to me, data wrangling is everything before you put it into a model.
Okay.
I mean, it's all of like making sure the nulls are checked, like that, the data quality is high, and like transforming the data and engineering the features and just like playing around to get the final data set that you will then put into a model.
Okay.
That's like data wrangling. And in theory, data wrangling stops here. All of this is data wrangling. I mean, because this features data is also like feature engineering. So we make totally new features from the data. I mean, in the end, this is all data, right? But that's data science terminology. Is a feature is the data that's actually used in the model, and the clean data. Yeah, some columns we just take without doing anything to it. Yeah, and here it's a feature, and here it's not. But yeah, so basically that stops here. But yeah, we still do, data engineering at Essent at least, we still do yeah, the data science, just at the very end. We focused more to make sure that everything is very robust and that every morning when we come in that everything is running and that, but we also focus on adding new use cases where we can.
Thank you.
When you do the features data, so with the clean data, you actually prune the data and remove information.
Yeah, rename columns, all of these things.
When you do the features data, you add information to the clean data, right? But
We don't add any external sources. Well,
okay, yeah,
sometimes we combine
that was the
multiple.
question.
So yeah, external data, right? What does this mean? This is like 50x databases. Sometimes we combine a bunch of stuff from different databases. Sometimes we just calculate like complex calculations between multiple columns that will come up with a new column and
So
things.
that would be the feature data.
Yeah,
Okay. And the use cases means
the machine learning model.
machine learning model. Okay.
Yeah, at least that's how it terminologically. So here would be like a linear regression or a neural network or
Mm-hmm.
whatever it's doing, and then that will write out a prediction, a score, a suggestion, whatever it will be, and then that's where the business people pick up. Any more questions?
You extensively explained it, but I kind of forgot. So,
It's okay.
what is Zeppelin against? for?
So Zeppelin is a sandbox. It's like
Oh,
Jupyter
it's-
notebooks. The Jupyter notebooks. Have you ever you use Jupyter
Yeah,
notebooks,
yeah.
right? So it's exactly like that, except for it uses like 20 languages instead of just Python and R.
Oh, okay.
So it actually looks like Jupyter notebooks. It feels like Jupyter notebooks. It's more or less Jupyter notebooks, but let me go show it again. So yeah, I mean, yeah, I didn't pick a very good example, but this is actually like, one of those blocks in a
Yeah.
Jupyter notebook,
Okay.
and then this is the code, and then so here's a Spark code, and then here's SQL. So
Okay.
it has this really nice mixing of code to use tools for certain, it's just for really okay, we get a new database, what can we do with it? What does the data look like? Let's go into Zeppelin and actually look at the data or count some statistics on the data or something like that.
Maybe a very general question, because I'm not that much into data mining and especially not in data engineering. Why is it useful to get so many different languages? Like if you say we can combine over 30 languages, why not keep up with, let's say, 1, 2 or maybe 3?
Yeah, that's a good question actually. No, it's just mainly useful for combining SQL and Spark.
Okay.
So Spark, there's something called Spark SQL, which is then is there an example of that here? No. So Spark SQL, it's like SQL syntax made into functions. So you can take a data frame and do dot select.
Yeah.
But that's Spark SQL, but sometimes it's nice to write in a traditional SQL query, and then this allows you to read the data in Spark, do some things to it, load it as a view in SQL, and then just do any kind of SQL query that you want to do to it.
Because it's more efficient, or
Yeah.
Okay.
Yeah.
Because otherwise I would say it's easier to let's study just one language,
Yeah.
master it and just keep up with one.
Yeah, well, if you're asking why does the data scientist use R and why do we use Spark, right? Why doesn't the data scientist just use Spark? There's a very good reason for that, and actually we tried to pick the furthest language possible for the data scientist no, really, yeah, because we didn't want data science code to end up in production. We didn't want the data scientists to think, let me just fix it real quick, and then go in with themselves and just copy and paste their code, and now it's running on 40 terabytes of data, and someone is expecting that So it's by separating the logic, you have someone that can do exploration, and then you have a very specific language that's very good for working at scale. I mean, R wouldn't even work on all of our data,
Okay.
but so that's kind of why we use different languages.
Okay.
There was another question here in front.
Oh yeah, sorry.
How much time does it take all the process?
When it actually runs.
Yes, when
Yeah, it depends on the use case. So some take 4 hours, but some take 10 minutes.
And do you have any verification methods if the business cases are sensible or not? Do you verify it? I don't know. I'm also quite new, but I'm
yeah. You mean Like, is it useful? Like, is it right? Is it accurate?
Yes, what I am.
Yes. Well, we do like training and testing, and actually, for some of our use cases, we know what has happened. So like, yeah, in machine learning, how you do training and testing, you know what has happened for like 30 days, and then you test on that, and then yeah, in the end, we do collect the data to compare in real life. So after training and testing, building our model, and we're running it, we do keep track to see if it's right, if we're making proper predictions or not. If you're thinking about like, so if you, I thought for a second maybe you wanted to know how long, I went back in the beginning of my presentation, I talked about this data science pyramids of needs and how companies want to start here, but I'm really happy that at Essent we started here. Basically this part, we've been building for 2 years. And this, we've been doing for 6 months, and this we haven't started yet. So it's really a long process. But that's a little bit about the culture of Essent, is that we, the management 3 or 4 years ago decided that they want to build everything in-house, everything using open source tech. So all of our billing, all of our systems now are moving to being written in open source and managed internally. And that's when they decided to also build a data platform.
Are there any other data platforms that you know about out there, or like every company has so far been building their own data platform, I guess?
Yeah, well,
So is there any other open source project or?
open source end-to-end, not that I know of. Open source closed source projects, yeah, of course, something like NG Data. I don't know if you know it, it's a Belgian company. They have like the Lily platform or C3 IoT. There's a few out there, but the problem is that yes, data engineering is very. I'm not saying this just because I'm a data engineer, but it's very complicated, and at the end of the day, you always have to transform your variables in a way that you need to transform them, and I can't imagine that there'll ever be like some graphical software or something that just can do it for you, right? Because the most efficient way, in my eyes, is that you have to program it. I mean, you're always going to have to take your column and do something to it. And the fastest way to do it is to program it. So that's why I think for the time being, every company should be building its own data platform. Because every company has a unique data landscape.
Do you think, also a basic question, but do you think it's easy to come up with a kind of, if you have a data model where you base yourself on machine learning and you know that this is the format where you would like the data model into, to build using NiFi or other applications to build some standard connectors to all kinds of data sources so that you could standardize that process a bit further?
That's what we do. But that's what we do for ourselves. It's not standardized.
Yeah, you do it for one company. But
yeah.
Is it a utopia to do it for multiple companies, even maybe within one sector, or?
Within one sector, that's possible. I mean, actually, the system that we're building at Essent is in the process of being spun off into a company called Utilities as a Service.
Okay.
And they will try then to, not the analytics part, so not what we do, but all of the other. For now, maybe in the future, what we do will also happen. But for now, the actual Essent platform, which is just like their billing, their customer CRM, like all of that will be sold to other utility companies.
Okay.
But I think for the data part, I think it will be still really hard.
The analysis part.
Yeah. I think it will be really, really hard because the data quality is always going to be different. What features you need to build is going to always be different. You know, it's really.
Yeah.
I don't see that it's easy to standardize.
Well, I've seen that kind of attempts to standardize also in other contexts, and that failing is maybe the wrong word, but it becomes so complex that at some point the original goal is not achieved anymore, and indeed it's better to find your own subset of that, and so eventually. I was just thinking of an example in our branch. Here at Avis we give courses. Okay, if you think of I want to follow a course or I want to give a course, so this setup and to exchange information.
Yeah.
Should we set up a format for that kind of information? What's important about the course? Yes, the date, the length, the topic, and so on. And you start, what is the what standardized is? Which set of features do we need? Impossible, apparently.
Yeah.
Although it's such a simple problem, and even there,
Mm.
there are maybe 5, 6 platforms that all say we are the standard, and well, they
Yeah.
are even not.
That's the same, and they,
to our needs, let's say.
and they all try to tell you in data engineering, our platform does everything. they always, I've been to more than a few sales pitches, and
Well, actually, it does everything, but it's probably very, very hard to get there. Like, then you have to code everything.
that's the whole thing. Yeah, it might do everything, but you have to program it then, and then it's worse because it's closed source, so you have no idea how it's working. And if you want to do something that they don't have already implemented, you have to wait until they implement it, or you can't do it yourself. So, but a lot of times the problem, the engineers aren't making those decisions, right?
If only.
Yeah.
If only.
Essent is quite good with listening to our concerns. So, hence we use all open source tools.
You send this video to your boss, and
Yeah,
he knows.
yeah.
Do you think there's some kind of no free lunch theorem for data engineering workflows?
Yeah.
What's that?
I mean, by this because data is so different, you can't find one workflow that is able to handle everything, but rather we should make some specific workflows for specific data.
Yeah. I mean, it's a little bit like any other kind of software development, right? I mean, yeah, there's like frameworks that come out for web development, but at the end of the day, every company needs a website that does what that company needs it to do, and you can't just, there's some things like WordPress or Wix or whatever to just like drag and drop some website, but those are all like, the most you can do is like a landing page. If your website needs to be hooked up to databases and actually do something other than just look nice, that's actually not really possible to do with just a tool. You have to program it.
Okay.
Yeah, it's general software. If your business is unique, then you will need unique software, which is custom software. And that can be.
But also even if it's not unique, no, like unless it's the same thing that everybody's doing, then it becomes some kind of uniqueness within the kind of common way of doing, like web frameworks, for example. There are a bunch of them, but if you call it yourself, then it's maintainable. You want to change something, then you know how to change it. It just works much better. Doesn't take as long to execute. So there are certainly upsides to implement things that are personalized. Of course, then you have to put the effort into it. If you don't care that much, it's like a business decision at the end of the day. If you don't care that much about it and just want a simple, cheap solution, cheap solution will work.
Yeah.
There's the book about this called The Master Algorithm, which deals exactly in the definition of an algorithm, which is defines learning in itself. So you can to define one algorithm for everything.
Okay.
Right? You can read it.
Sounds like
I just said about it.
Okay.
It's really interesting. It goes along the path of machine learning, how it came to be, the statistic view, the evolutionary view, the whatever, the biological view, the whatever, and it explains each step, the neurological point, and it goes to each one of them and explains how it goes. You understand what's behind the machine learning at one step. At one point in time, you stop reading it, as I did, so and haven't finished it, so I cannot tell you.
So you don't get any spoilers.
The master algorithm, it's called.
It's easy read. If you're a little bit technical, easy read.
Okay.
Cool.
Good.
Other questions?
No.
Awesome. So again, thank you very much.